You guys have probably been wondering, hey, this is geometry class. When are we going to get into some shapes, right? Well, today is the day. We are going to start into two-dimensional figures. You're looking here in our textbooks on page 56 if you want to follow along in your textbook. And I do encourage you to take notes, obviously, as you go. So two-dimensional figures is the topic of the day. We're going to really focus on this first definition here, which is a polygon. So we want to be able to identify whether or not a shape is a polygon. So a polygon is a closed figure, all right? So it's a closed figure formed by a finite number of coplanar segments called sides, such that the sides have a common endpoint. The sides that have a common endpoint are non-collinear. All right, so they're non-collinear, they're not collinear, and each side intersects exactly two other sides, but only at the endpoints. Okay, so this is a very important definition, that you get the whole thing down and that you study it. Basically, in a nutshell, like a polygon is going to be an enclosed figure that doesn't have any like weird sides sticking out solo, no gaps, no curves. Okay, so we could draw something that looks something like this, and then it goes this way. Oop, that looks too much like a curve. This way, and then maybe it goes this way, and then maybe it goes this way, and then maybe like that. Okay, this would be considered a polygon, all right, because the sides that have common endpoints, they're all non-collinear. Each side intersects, so if you look at this, each side, like let's just look at this side here, for instance. If I look at this side here, it intersects exactly two other sides, being this one here and this one here, and only at their endpoints. Okay, so endpoint here, endpoint here. So a non-example, would be something like this. Maybe I can draw something that's similar, but as a non-example, something like that, where this last piece just keeps going off. So if we have any of these weird extensions, that is not considered a polygon. Also, if we have a gap, right, so like that, something like this, not, so these are non-examples. Anything with a curve as well, so if I have something like this, like something that looks like a lemon, that's a non-example as well. So we're looking for straight edges, okay, like a triangle would work, right? A square would work, a rectangle would work, a pentagon would work, and even these types of shapes here would work. But again, straight lines, sides that have a common endpoint are non-collinear. Each side intersects exactly two other sides, but only at the endpoint. Okay, so that's polygons. If you want to look at more examples and non-examples, there's some on page 56. Next, once we know whether or not we're dealing with a polygon, we can also be a little more specific about our name. The name comes from the number of sides. Okay, so this chart actually is, there's two sections to the chart, just so you're not confused. So if we have three sides, we call it a triangle. The key piece to that name there is tri, meaning three. For four-sided, we have quad, quadrilateral. Five-sided, we have pentagon, pent meaning five. Six-sided is a hexagon. Seven-sided is a heptagon. That's the one that I always got confused for some reason. And then the eight-sided one was an octagon. Nine-sided is a nonagon. 10-sided is a decagon. 11-sided is a hendecagon. And then a 12-sided is a dodecagon. I would say you should at least have memorized all the way up through 10. These last two we don't use as much. It's good to still have an idea of what they are, but I would at least know those guys if you don't have them memorized already, it would be a good idea to memorize those. So if I said, what's a nonagon? You could readily identify that that's a 9-sided polygon. Okay, so onward to concave versus convex. So keyword here is this part of the word that we see here that is a cave. So any polygon that has a cave or has an overhang is going to be considered concave. The way that you can test this is if you have a shape and you extend any edge, the edge cannot cut through the shape. If it does, it is concave. All right, so I'll do this here. Let's just look at this line CB. This is an edge, right? If you extend that edge out, if it cuts through the shape, which it does, it is concave. All right, this one would be another example, right? Because if you extend this side out, it goes through the shape, it is concave. For convex, if you extend, that's a typo, if you extend, not extent, if you extend those edges, they must not cut through the interior of the shape. So notice if I extend this guy out, it doesn't go through the shape at all. Same with this guy. If you extend all these out, none of them are going to cut through the shape. Okay, so that's your nice little test. The extensions cannot cut through if it's convex. And then we have this regular polygon. So a regular polygon is first of all, this is key here, it's convex. Okay, so if something is concave, we never call it regular. So that's a little side note, but it's not a regular polygon if it's concave for some reason. It's a convex polygon if it is both equilateral and equiangular. So what that means is if all sides are congruent and all angles are congruent, these are the congruent symbols for sides and angles, then I know I'm dealing with a regular polygon. Okay, so the sides and the angles. Irregular is just everything else. Okay, so for this one, notice I don't love the definition that I put here, but for irregular, anything concave is going to be irregular. And then anything that does not have equal sides and equal angles obviously is not. So the reason for the reason that it is not regular with concave is simply this. This angle here has to be compared with this angle here. Those are clearly not the same angle. That's why no concave shape will have all the same angles inside. You might see something that labels that like these are all the same, but you have to remember that you have these other guys, these angles right here, right, that are different. So maybe we'll put 2 rings around those because they're probably, those 3 are the same, these 4 are the same, but these are different sizes. Okay, so example 1, let's label these things in 3 ways. We're going to name the polygon by the number of sides, we're going to classify it as convex or concave, and then we're going to call it regular or irregular. Okay, so the first one, 1A, has 4 sides. That's a quad. We can just abbreviate here, that's fine. Is it convex or concave? So I can do my little test here if I wanted to do my test. This one's pretty straightforward though. It's going to be convex. There's no cave to it. And then it's tempting to say that it's regular because we have all the same size angles. But notice this side here and this side are the same, shown by this one little mark here. But then the other 2 sides, so if I switch colors here, this side and this side, these are the same, but they're not all 4 the same. Does that make sense? The 2 blue ones are longer than the red ones, therefore this is a irregular. Okay, for my next one, if we count the number of sides there, we see that there are 10. So this is a decagon. Decagon, dec meaning 10. And then if we extend the sides out, we do cut through, so this is concave. And if it's concave, I already know it's going to be irregular. Again, the reason is you might see that all of these angles are the same, right? Because they show that they're all the same with the congruent sign. But the ones that they did not show, these guys, these angles are not the same as those angles. So we have to consider those as well. And then for 1C, we have all the same sides and angles. Okay, so we know that we're dealing with something that's regular. So it's regular, it's convex, and then how many sides do we have? We have 6. Okay, so this is a hexagon. Hex means 6. Then we have the fact that it is a convex. Okay, and then we also know that it is regular. All right, guys, the last thing we're going to get into is some area and perimeter of basic shapes. So this should be somewhat of a review from like 7th grade, 5th, 6th, 7th grade. We did a bunch of this stuff. I say I probably didn't do it with you, but somebody did. So just to review, perimeter is always just adding up the length of the sides. On a circle, there's a little bit more to it, right? It's still the same idea, but there's a little bit more to the calculation. With area, just a really quick thing here. Area, you guys. So let's go back to just really basic definition of area. Okay, let's say that we have something that looks like this. Okay, area is the number of 1 by 1 pieces that make up a shape, right? So if I have like this rectangle here, notice I have 2 rows and 3 columns that make this thing up. If I count all of these, it's just going to be this number times this number is going to tell me how many 1 by 1 squares I have. That is area, right? So for a square or a rectangle, it's just length times width, right? Really, this applies to both this and this, square and rectangle. But with a square, it's always going to be the same, right? So if it's a square, it'll always be like a 2 by 2 or a 3 by 3 or a 4 by 4, etc. So I could just take one side and square it. It'll always give you the same thing though. Like 2 squared is equal to 2 times 2. So I can always do length times width with those two things. Then for the triangle piece, you guys, just so that you can wrap your minds around this, I know this is review, but if we cut one of these squares in half, then we have the triangle, right? So it's the same exact thing. It's 1/2 base times height. We call it base times height here instead of length times width. Okay, because we have the base of a triangle, we have the height of a triangle. The height is always going to be at a 90 degrees, okay, on that triangle. So that is a triangle. And then the circle, the distance around a circle is just pi r. Sorry. Yes, 2 pi r. I was looking at the area. 2 pi r is going to be the perimeter or the distance around the circle, and then the area of the circle is going to be pi r squared. Okay, so let's use some of these formulas. For this guy here, since this is 6 feet, this looks like a square, but it's not, because this is 6 feet, this is 5.5 feet, so this is a rectangle. So in order to get the perimeter, okay, I know that that's going to be the same as this one, right, because these are all at 90-degree angles, and this is the same as this one. So to add these up here, this is going to be 6 plus 5.5 plus 5.5. That gives me 11, that gives me 12, so therefore this is 23 feet. My area would just be length times width, which is 6 times 5.5. If I do 5.5 times 6, well, every 2 5.5s gives me an 11, and so I have 3 of those, 3 sets of those. So I'm looking at 33 feet squared. Okay. And then let's do 2b, the circle. So for the perimeter of this circle, we have a diameter of 6.2. Diameter is the same as 2 times the radius, right? So it's double the radius. This is all review, I know. So this diameter, 6.2, we're going to take that and we're going to just multiply it by pi. So 6.2 times pi. And when we do this, we will get, let me just pull out my handy calculator here. Sorry for the delay, I should have had that out. 6.2 times pi gives me 19 point, we'll call it 19.5 centimeters. Okay, and then for the area, it's just going to be pi r squared. So the radius of this thing, half this distance, the radius is 3.1. All right, so we have pi times 3.1 squared. If you take 3.1 and you square it, you get 9.61. You multiply that by pi, and you get 30.2 centimeters squared. Okay, so that's for 2b. Moving right along to the triangle now. So we get kind of a taste of each one of these here. For the triangle, what we're going to do is we're going to add up all the lengths of all the sides. So 9.5 plus 9.5 plus 10.2. And when I do that, I get, let's see here. This would be 18, 19. 19 plus 10.2 would be 29.2 inches. And then for the area, it'll be base times height. So the base of the triangle is going to be 10.2 times the height. The height is the 90-degree height. That is very important. So I have 10.2 times 8 divided by 2. Okay, because it's 1/2 the base times the height. I could do a little bit of simplifying here. So this is the same thing as this. 10.2 times 4 gives me 40.8 inches squared. All right, so that's example 2, where you're just plugging things into your formulas for areas and perimeter. The last thing, you guys, is they'll have you do a couple of these where they're asking you which one of these has the largest area. A circle, so there's 32 feet of fencing. So that's important to keep in mind. We can't go over 32 feet of fencing, right? So that's all he has. Which shape of play area uses the most or all of the fencing and encloses the largest area? So we want the largest area. We want it to use 32 feet if possible, but we cannot go over that, right? So let's just check this out. So a circle with radius of 5 feet. Okay, so let's do pi. The radius is 5, so pi times 5 squared. So that's 25 pi, right? 25 times pi. That gives me 78.54. All right, so the circle gives me 78.54. The rectangle is says the length is 5, the width is 10. But let's think about that, you guys. Let's just make sure that that works. Okay, so if this is 10, this is 10, this is 5, this is 5. Yeah, so that uses 30 feet of fencing. 10 times 5 gives me the area. So 5 times 10 equals 50. But clearly it's not going to be this one because the first one was bigger, right? Then we have a right triangle with legs of length 10 feet each. So this is 10, this is 10. So this would be 10 times 10, which is 100. 100 divided by 2. Base times height divided by 2. 10 times 10. 100 divided by 2. That gives me 50 as well. Okay. And let's check the last one here. A square with side length of 8 feet. So this would be an 8, 8, 8, 8. Distance around is 8, 16, 24, 32. Okay, if I multiply 8 times 8, I get 64. Okay, so the one with the biggest area is going to be this guy right here. And we're good to go. All right, guys, that's all I have for today. Check your homework sheet for your homework problems, because I don't think I give you this many. And we'll see you guys in class.